that what is debugging? It's the process of hunting down of errors, finding it, and then rectifying it. There are many methods. Brute force method, we are checking randomly, like what are the errors that may take place. Okay. Backtracking, we are starting from the last part of the line of code, and then we are going back of the source code to track where the error has been occurred. Cost elimination method, we try to see like what are the various symptoms that may be that the error has resulted, and accordingly the test may be conducted. Program slicing means it's similar to like backtracking, but here we slice the program. Okay, slice means we break it down, okay, into various source lines, and accordingly we hunt the errors accordingly. Okay. Now, whenever we are performing debugging, then what are the things we need to do? So, debugging is often carried out basically by the software developers. Okay, the following certain guidelines that one needs to follow. Like many times, debugging requires a good understanding of how the program was being developed. Okay, a person who has developed the program, only he or she only will be able to understand the flow of the program, and if suppose there are certain kind of bugs or errors, then be rectified in the implementation phase. Okay. Now, whenever debugging takes place, certain times what may happen that your logic or the way you have approached the program is not very clear. So, what happens that you need to restructure the flow of the program, or maybe you need to redo the entire designing of the program. Okay, so in that case, debugging may take a lot of effort depending upon the errors that may have taken place. Okay, and also it may happen that in certain situations that you went to correct a certain error, but in place of that, many other errors after correction have taken place. So many things may take place. Okay, so we need to be open with how things are being corrected and hunted, so that there should not be any kind of issues. Okay, then whenever you are performing an analysis of what are the errors that may have taken place in the source code, so certain situations and considerations you have to take place, like what is the size of the, how much complex, how much space it is occupying, what is the efficiency of the time of execution of the particular source code. Okay, does it follow the programming syntax that we have basically taken? So many things are there. So whenever we are performing such kind of analysis of to locate the errors, then there can be two types of tools which may help us for finding out the errors. Okay, so first is the static analysis tool. So this is also a program analysis tool. So what this does, it checks and finds out, okay, the characteristics that that particular product should be having, okay, without actually executing it. So how will it be able to find the characteristics? So first of all, it will see like certain things, like whether it is following all the suppose if a software product is being made in a particular language like C, so it has to follow the syntax, the grammar of that particular language. Okay, so statically that will be analyzed without actually executing it. It will see if certain variables are there which has not been used, or which has not been initialized, or maybe you have a function where there are 2-3 arguments, but you are passing only one argument, it is not matching. Okay, so all these things are there. So if suppose while checking the source code you encounter this thing, then we say that we are analyzing this in a static way. Okay, so code walkthrough and code inspection falls under static analysis method. Whereas dynamic program analysis tools is basically again a method basically to check if suppose any kind of anomaly or error or maybe bug has taken place. So if suppose that is there, then the those errors or bugs or maybe how it is behaving, it is recorded. Okay, the code which basically throws such kind of exception, basically that part of the code is located, and we try to hunt the error and correct it. Okay, so how do we do that? We test every line of code with particular testing techniques. So we will see what are the various techniques that we have. Then we will see what kind of output or reports are being generated, and accordingly we try to note it down that on what kind of data inputs or maybe uh, method that we are following. Okay, what kind of output we are generating. If suppose the output is like okay, what we expect we are getting, then it's fine. But if not, then we need to find out. Okay, then this kind of analysis basically can be represented in the form of a report, in the form of a pie chart or histogram, that suppose we have tested this, how much percentage of accuracy we have found in the results, okay, how much percentage of quality has been found. So all those things can be represented with a pie chart or maybe in a histogram or maybe any kind of a frequency polygon to demonstrate the accuracy and efficiency of the code. Okay. Then next is the integration testing. So what can be an integration testing? Can anyone tell me? We talked about unit testing earlier.
So like different modules are like put like integrated together and like maybe they're tested if they're like working with together, like if they're
Exactly,
like in
correct.
sync.
Yes. So in unit testing, what we are doing, when one module is made, we test it unit-wise, singly. So when all the modules have been made, so we club together, okay, we combine them together. So once they're combined, it may so happen that one module may not be working very nicely with after the integration or combination has been done. So in that point of time, it may throw some kind of error or exception. So integration testing basically will check that how basically the system will be behaving after the modules has been combined. So this testing approach basically is followed by these four approaches are there, like Big Bang, bottom up, top down, mix. Okay. So in Big Bang integrating testing, what happens is it is also called up to be the simplest integration testing. Okay, where all the modules are combined, okay, in a single step only. Okay, so what I wanted to say is that these modules are combined together and then they are tested. Okay, but this is very much approachable or feasible for if you have, let's say, only 4 modules or 3 modules when the software product is very small. Then this kind of integration testing is very much feasible. But let's say you have a which is comprised of 50 modules, 40 modules, then that will not be a very correct way of approaching, because so many modules integrating, one module may not be behaving in a proper way once the integration is done, or one module may be platform dependent. Okay, so all those things may be there. So that's why for small systems it is fine, but not for the large one. For small systems, what happens is the benefit of integration testing is that it's very easy to find out like the errors and which module is basically throwing this kind of exception or error. So it becomes very easy for us to correct the errors. Okay. Now in bottom up approach or is test tested. Okay, subsystem may have again submodules. Okay, which may come another. Okay, through some defined interfaces. Okay, so let's say we have one system. A system may have 4 subsystems. Again, each of the subsystems may have, let's say, 2 modules, 3 modules. Again, each of the modules may be doing message passing. That means they might be sharing some kind of information through some kind of a medium which helps them to communicate. Okay. So in this case, what happens is that we cannot test the entire system. We have to test the subsystem, but before testing the subsystem, we have to test the modules of each of the subsystem and also the interfaces or the communication medium that it is working correctly or not. Okay. So in this case, many things will come into play, like the flow of control of the program, the variables, the local variables which are there in the modules, the interfaces which are there. All these things are tested. So if they are working correctly, then only we can say the modules are working correctly. And if the modules are working correctly, then only we can say that the subsystems are working correctly. And if all the subsystems are working correctly, then what we can say? That the system as a whole is working correctly. So that is the reason it is called bottom-up approach. we are targeting the atomic level, okay, the lowest level that is there. That means the modules and the interfaces. If they are working correctly, then we are going up to the subsystem. And if all the subsystems are working, then we are going more at the higher hierarchy. That is the what? The system. Okay, so that is the thing. The only challenge that may be there in this case is that if the subsystems are too many, then in that case, it becomes very time consuming. The complexity increases, okay, by leaps and bounds. So that becomes a grave challenge, okay. Then next comes is the top-down integration testing, okay. So in the top-down integration testing, from the name itself, what do we do is that we may have a system, then we may have a subsystem. So accordingly, the approach flows from top to bottom. In the bottom-up approach, we are having the concept of testing from the lower level, and then we are proceeding upwards. But in the top-down integration testing, it is just the reverse way. Okay. So top-down integration, what will it do? First, it will test the subsystem. Then, after targeting the subsystems, it will go to the module, and then from the module, it will be going to the program interfaces, that whether they are working correctly or not. But in the bottom-up approach, it was just the reverse, isn't it? The mixed integration testing means it's a sandwich or it's a hybrid kind, where some parts of the subsystems are following top-down approach, some kind of systems are following the bottom-up approach, depending upon the requirement basically. Certain subsystems have lesser number of modules, then we can go for a bottom-up approach. If suppose certain subsystems have so many modules and program interfaces, then in that case we go for a top-down approach. So depending upon the requirement of the subsystems, we are basically going accordingly. Okay. Then certain approach follows basically one is the phased testing and the other one is incremental testing. So both are under integration testing only. So in incremental testing, what happens is that when suppose you have 5 modules, out of 5 you have 2 you have combined, then you will test. When 2 are combined, it is working correctly, you have tested, then you will combine the third one, then you will test. So it's working. So it's in the incremental phase, isn't it? One by one you are adding and then you are testing. In the phased integration, it means you are combining not only just one module, but a group of modules. Out of 5, you have combined all the 3 at one shot, and then you are testing. And then in the second phase, what you are doing, the remaining 2 you are combining, and then you are testing. But in incremental, you are going one by one at a time. Okay, like combining, then testing, combining and testing in that. Okay. So then some more things are there, like system testings basically are carried out depending again upon the various levels. So there may be 3 kinds of system testing. So one is the alpha testing. So alpha testing refers when you're developing the product you have developed. Okay, but you've not shared with the client yet. That means you have done the testing only with the software developers, the ones who have developed the product, and your company people. Okay, who have developed, the company has developed. So within those people only, within the company. Beta testing means you have done the testing, now you will go to the client side, and then you will sit with the client, and then what you will do, you will be performing beta testing is basically the system testing where basically you are performing the testing between a selected group of customers, friendly customers. It may not be the exact customer who has asked you to make the product, but certain other customers or people whom you know, okay, to check, like maybe it can be a friend circle or maybe your alliances, okay, whom you have asked that, okay, I have made this product, just give your review, okay. How have I made it correctly or not? Okay, so that may be there. So you may be asking your alliances or people, who you are there, who, from the same field, and you want to have a kind of a review from them, that whether the product that is being developed is correct or not. Acceptance testing is much more. That means in acceptance testing, what we are doing is we are performing the system testing, the software testing, but the client is also there who have asked you to make the product. The client can be an individual, it can be company. So you go to the client side, you sit with the client and you check whether all the requirement that was specified in the SRS phase, okay, whether it is everything there, whether the product has been developed as per the vision of the client, and if it is there, then it is ready for the acceptance of the client. So that is the reason it is called acceptance testing. So So this is very important. They used to ask like differentiate between alpha testing, beta testing, and acceptance testing. The next is the performance testing. So in the performance testing, it will check again, it will do a cross check with the SRS of the document, what is there. So basically, again, under performance testing, certain black box test has to be conducted. That means a test which will be only be done by the developer or the testing team, okay, without the knowledge of the client side, and we will not be more concerned of the program of the source code or the algorithm of how it was developed. Okay, it will be having a very abstract kind of representation, but we will be more focused on certain parameters like stress, volume, configuration, compatibility, regression, recovery, maintenance, documentation, and usability. So stress testing, what can it be? Stress means what? Endurance, isn't it? To endure or maybe to bear. Okay. So in stress testing, what happens basically? We try to see that till what level the system can bear different parameters. Okay, like for example, how much amount of input data it can consume at period of interval. Okay, how will data be processed? The input data will be processed. How much amount of memory space will be utilized? Okay, so that is the kind of stress for the system. Okay, where it is running. So that is the reason it is called stress testing. Suppose, for example, they have given here. I'll quote direct from here only. Suppose in OS is supposed to do 15 multi-program jobs. Okay, 15 like work it must do the system. Okay, the OS. Okay, but then the system that we are running or the product that we are running is trying to attempt to run 15 or more jobs at the same period of time. So what happens? That is a kind of an endurance that results for the soft for the OS or for the system as a whole, isn't it? Because its maximum level was 15, but we are trying to initiate to run processes which is more than 15. So that is a kind of an endurance. Okay, this is called as stress testing. Okay, then uh, yeah, suppose for example, we have made a system which takes a response time of 20 seconds per stress transaction. Okay, but when 60 concurrent users, that means 16 users, if they are operating that same system at the same period of time, then there will be a lot of stress which will be there on the system. So we have to check that whether the system will be able to take the stress or it will break down or it can generate any kind of anomaly. So that has to be also be taken care. That means, suppose for example, the system is taking what kind of variables, what kind of data type it is taking, what kind of data structures it may will be able to take. Okay, so according, if suppose it is using stack, it is using tree, it is using graph, it is using queue. Okay, then accordingly, the compiler which has been used for execution, isn't it, or for compilation process, then each of these information has to be stored in the symbol table. So if suppose we have used too many data structures where the memory occupancy is you can say rusted out, okay, we are not being able to put in, then what will happen? The symbol table will throw an exception that it is encountering a case of overflow. Okay. Then configuration testing. So here basically we are trying to analyze that whatever software and hardware requirements that we have specified for the development of the product is well met or not. If suppose it is not well met, then that has to be corrected, okay, in the configuration testing. Then next is the compatibility testing. So this type of testing is carried out when the system interfaces, that means the software interfaces, they communicate well with other system. Now system here can be modules also. Okay, so it will check whether it is being able to communicate in a more effective way, like accessing some kind of information from the variable, from the data structure, from the databases. Okay, all these things are taken care. Okay. Regression testing basically is the process of running an old module, okay, after which each change to the system or after each bug is fixed, okay, to check that no new bug has been introduced. So if suppose you have encountered that certain issues or bugs were there, you have uh, corrected it, and then you rerun that system to check if suppose no any other additional bug is there or if any no new bug has been encountered. Then testing basically it checks whether, suppose if there is a kind of a system failure, power device failure, or maybe so any kind of fault that may be there. So how will you be able to recover that? How will you be able to know how the system or the software, the entire thing has been configured or how it is flowing? So how will you do? We'll do a cross reference with the SRS because you have documented it. So you'll be able to know how will the system be supposed to behave, isn't it? You will retrieve all those information from the SRS. Then maintenance testing means you have to maintain also. So how you are going to maintain, you have to perform diagnostic checks as per the requirement and from time to time so that you are safe from any kind of unwanted bugs. Okay, documentation testing means you need to check the manuals. Okay, that was documented from the SRS phase till the manual of how the software needs to be like working. So all those things has to be documented. So these things are not required. The next topic we have is the software maintenance. Important. Software maintenance process models, which are also important. These equations is also very important. Try to finish the course by next week. Okay. Anyhow, anyways, we don't have much things to do, but many things are there. Okay, so for your test, class test,